Now that we have a bag of comparisons between players, teams, restaurants, movies, or whatnot, we want to come up with rankings between all of them. This is a tricky question. This question has been a difficult puzzle for centuries. The essence of the difficulty was captured in the so-called Condorcet paradox, which is named after French philosopher and political scientist named Marquis de Condorcet. In late 1700s, around the time of French Revolution, he was one of the leading thinkers in understanding what is the best way to elect leaders in a democratic society. Naturally, in elections, we are trying to elect leaders by ranking or ordering them collectively through our votes. In presidential elections in US, we cast a vote for our favorite candidate only. But suppose instead, we were allowed to cast votes in form of comparisons. That is, votes would consist of comparisons between pair of candidates. Precisely the setting we have been discussing. And this is the setting that Condorcet was thinking about. He considered the following hypothetical scenario. Let's say there are three options, A, B, and C. We can think of these options as candidates or restaurants or sports teams. Now suppose we have three votes. Vote 1, A is preferred over B. Vote 2, B is preferred over C. Vote 3, C is preferred over A. If we look at only first two votes, it naturally suggests that A is preferred over B and B is preferred over C. So that means ranking should be A be first, B be second, C be third. But the last vote contradicts this. Similarly, if we take any two votes and try to order options, we will have a perfect ordering, but the remaining third vote will contradict it. This is a paradox because we cannot order them in any meaningful way. And this is what makes ranking really hard. At this stage, if you are wondering whether modern political science or the so-called social choice theory has anything to do with our world of ranking and recommendations, you're right on the money. There has been a very long intellectual history in social and political sciences starting early 1900s. And lately, statistics, computer science, and mathematics have been active in this broader topic due to various modern questions, such as the topic of our discussion today. I would suggest an interested listener to read up a few notable works. 1. A Law of Comparative Judgment by Louis Thurston, published in 1927 in Psychology Review. 2. Social Choice and Individual Values by Kenneth Arrow, published in 1951 and republished in 1963. Back to our Condorcet paradox. Clearly, it applies to our setting and hence we need to resolve it. So how to resolve it? Well, one way to resolve this is to try to assign scores to each options. The scores in the setting like above will be equal for all options. That would be a successful resolution of paradox for the particular three-vote scenario. And when it would make sense, the scores might be different for different options, leading to a global ranking. Let's start with one such simple approach. To recall, we are given a collection of votes or opinions in form of comparisons. Given this, we want to assign scores to all options. And here is how we are going to do it. The score of an option equal to the number of votes or comparison in which it is a winner divided by the number of votes or comparison in which it is present as either winner or loser. Use this score to rank the options. The option with highest score is top ranked. For option A, it participates in 2 votes, of which it wins in 1, therefore its score is 1 by 2. Similarly, score of B and C will be half. And this resolves that paradox, nobody gets higher score than other.